Well, thank you. So I really do want to kind of demystify this thing. And again, I think probably the part of the problem is that people don't often select data analyses. But let's just get to it here. So, you know, the question that people have come to for like going on 30 years, what test should I use? Um, so it's a very simple formula that I use, and I will get there. So really, the data analysis plan is really just a combination of your study aim or research question in statistical language, which I'll explain, and then the levels of measurement of your constructs or of your variables. That's it. That's the whole shebang, okay? And if you know those two things, you can kind of get to the data plan that is appropriate. So statistical language has lots of ways of phrasing things. For me, the three broad ways are the relationships between these two variables, are there differences on some variable by some other variable, um, and does one variable or set of variables predict an outcome variable? So, but to get to those, you need both that language and the levels of measurement. Having said what I just said, there are faculty and there are, some people talk about relationships, but we're kind of doing regression. So there's some variation there. But in general, if you stay with relationship language, differences language, and prediction language, we're kind of in the right direction. So go over the three levels of measurement. Nominal is Latin for name only. They're just categories, red, blue, green, squares, okay? Ordinal have names like small, medium, large, um, but it has an order to it, okay? And you can see the kind of the bar graph there to kind of represent that. And those icons come into play in the tool itself. And then there's scale, which have names, 1 inch, 2 inch, 3 inch. It has an order, but it also has equal intervals between it. So equal spacing or equal volume or things of that sort. I did get a email recently, which is, hey, we teach ratio and interval levels of measurement, and no problem. But for the data analysis plan, really, if it is ratio or is interval, or some people can call it continuous or scale, the same analyses apply. So I kind of bucket all of those terms into scale. All right. All right. So once we know that we're looking at relationships, okay, between two nominal level variables, okay, the test is a chi-square test, okay, and you can see nominal ordinal and ordinal and scale scale. That's it. Everyone's going to get the recording. That's your cheat sheet. That's how it goes, okay? Um, I guess I can give an example here. Nominal, is there a relationship between diagnosis and not and male and female, two nominal level variables? I can examine if there's a relationship between those and do a chi-square and so forth. And I can do some of these tests pretty quickly inside of the tool when we get to that, which will be shortly. So relationships, good cheat sheet. And Melissa, as I think about it, I'm thinking, hey, you know what? Why don't we just give these cheat sheets to everybody who's on the call? We'll just give them these three slides and let them have it. So, okay. Differences kind of questions. Very often we're looking for differences either from pre to post, or if there's differences on, runtime or emotional intelligence or any other scale that's continuous by some groups, okay? So when your DV or dependent variable is scale and your independent variable, your IV is nominal, the question now is, do you have two groups or three or more groups? And that decision is kind of the t-test or ANOVA. You have a scale by an ordinal, same thing, t-test ANOVA. Once you get to ordinal, by nominal, we're either in a two-group Mann-Whitney, the Wilcoxon is a parity test, or the Kruskal-Wallis if you have three or more groups. The caveat to this is that with the t-test and the ANOVA, there's different assumptions of normality, which is basically that the shape of the dependent variable looks like kind of a bell curve, and of homogeneity of variance, that is that each group's standard deviations are similar or homogeneous to each other. And if those assumptions are violated, you can wind up into a non-parametric, which is that Mann-Whitney, Wilcoxon, Kruskal-Wallis, and Friedman. So, but at the outset, I would be identifying those tests as they are here, and then deal with assumption violations thereafter. When it comes to prediction, things get really easy. Everything is based on the outcome variable, and that outcome variable is either going to be nominal binary, okay, live, die, okay, whatever that binary variable is, okay, Coke or Pepsi or whatever, okay. Once you have that dependent variable identified as two levels, okay, it doesn't matter what the independent variables are. It could be any range of levels of measurement. We're going to be doing a binary logistic regression. If you have nominal with three or more categories, we're into the multinomial logistic, ordinal regression, and scale linear regression. It's also called multiple linear regression when you have more than one predictor. But that's it. Not rocket science, but you need to know to learn somewhere. What tests go with what question and level of measurement, and this is the basic template for that. Okay. So to kind of summarize here, we want to know what kind of research question we have, okay? Are we looking at relationships or differences or prediction? What is our level of measurement? And then how many groups do we have? That's kind of our framework here, okay? And here's a quick reference down below. So I'll get to Intellectus Statistics in just a moment. It does have a built-in decision tree to kind of walk you through what I just said. You need to know what level of measurement you have, though, okay, and whether you're doing differences, relationships, or prediction. Has lots of different tests. Show you that. One thing about Intellectus is that for many of these tests, there are assumptions built into it, or that assumptions should be assessed. So in the tool, those assumptions are automatically assessed and interpreted. And then you have formatting, so you're not messing around with tables and that kind of business, which I used to have to do back in the old days. We had to format every table. Now it just spits out. Okay, so let's go look at the decision tree. I should mention the idea of power analysis. And power analysis is once I decide what my statistical test is going to be, I should determine what's the appropriate sample size to have power or 80% chance of finding differences or relationships if they're there to be found. So we'll look at both the, decision tree, figure out what test, but then also look at assumptions and look at a power analysis as well, or sample size determination. One other quick thing about the sample size is that some folks, for most research and for most dissertations or scholarly projects, really we're using a power analysis to determine the sample size. We are not using the whole population. We're not going to generalize to the whole population. Okay, we're just kind of saying for that test, here's the appropriate sample size. So without further ado, well, maybe not. Let me just, I'll get to questions and answers. And let me just put up really briefly that just so you have this as a reference, you can take a picture of this, that Samantha can support students, Ashley can help faculty with courses, with demos, with trials, and Melissa can answer every other question. And there's some contact information for you. And you can talk to me for 20 minutes with that QR code. Okay, so let's get to the tool. Get out of that, get out of that, and we are here. Okay. Melissa, should I stop for quick questions?
No, I think we're okay right now, but please feel free to enter questions at any time and we'll stop for them.
Good. Okie dokie. So I've just entered in a silly data set, which has ordinal level variables. So age groups, let me just look at that. So, it has different age groups, okay? Nominal is just kind of names of things, okay? In this example, movies. And then also fruit, just groups or nominal. And then I have some scale level variables like amount of hours of sleep or GPA pre and post. So, and just to kind of share too that, really the first four are really the analysis part, um, uploading data and managing data and visualizing data and analyzing data. But we're going to be dealing with these latter ones here, okay? So the decision tree is just really one way of getting to, in a user-friendly manner, of getting to um, answering some basic layperson's questions and getting to the tests over to the right. Again, we're not getting to, mediation or other kinds of analyses, but we are getting to, again, a vast number of tests that most people use. So let's just look at those differences and prediction and relationships. So makes me want to test everybody, but if we look at relationships and I have all scale variables, I'll be doing a correlation, and then you can just jump to that Pearson correlation and conduct that test. If you are looking for prediction, and I have the outcome variable, again, is the key, right? And the outcome variable is scale. I'm doing a linear regression. And if I want to look for differences between groups, I have, let's just say, one dependent variable. Could probably ask that question better. Do we have more than one dependent variable? I'll say no. Okay, so just one variable. We've not talked about covariates. Briefly, covariates are variables that you want to control for or neutralize the effect of. And covariates come into play when your potential covariate could be impacting your outcome variable or your dependent variable. For example, I'm looking at 5K race times by gender, but I notice, hey gosh, all the women are 30 and all the men are 85. Maybe it's age that is affecting runtime. So I might want to use age as a covariate there. So I'll say there's no covariates. I have just one independent variable, let's just say that, which is just two levels. All right, so I'm into conducting an independent t-test. Again, the Mann-Whitney would be that non-parametric equivalent test when an assumption of the t-test was not met. You click on it and you jump right into it. I should note while I'm here that that there's video tutorials, like 2 or 3 minute video tutorials. There's 60 or 80 of them inside of each one of the different tests, which we don't really want to get to right now. Okay. So just to know that videos are built out throughout the data management. have no missing variables. So you have little video tutorials built in everywhere. And in plots, you have video tutorials built in. And for all the analyses, you have videos built in as well. You can also get the videos up here under the question mark and click on videos, and you can see a whole range of different videos bucketed by different topics. Okay, so let's get to, so we just worked at the decision tree. Once we know we're doing a t-test, the next thing for a data plan is to talk about the assumptions of that. You can click on assumptions and click on the test. And here, I know DMPs are really not using research questions, but you could have this as, or hypotheses, but you can have a study aim. But then you'll need some of this information here, which is the assumptions with references. So you have to edit that as well, but you can download that here, okay, and then edit that assumption. So, and then the final thing we want to do is really do a power analysis, which is once I know I'm doing a particular test, okay, that what is the appropriate sample size given that test? Effect sizes, I'm giving you 3 sample sizes for different effect sizes. Slightly counterintuitive, that small effects are difficult to detect, the importance of the difference or prediction. So thus you need a larger sample size to detect small effects. For very large effects, big differences, you need fewer participants to detect that. The other piece of that, and by the way, if you just use medium effect size, I think that probably gets floated pretty good for many committees or journals. The real official way of doing this, by the way, is to look at past literature. If I'm looking at some particular emotional intelligence scale, and I could look at the previous research and say, hey, gosh, they found a small, medium, or large effect. That can be the theoretical basis to select an effect size. The other aspect is not only theoretically assessing effect size, but practically. Hey, gosh, my previous study or previous studies that I looked at have small effects, but there's no way in God's earth I'm going to get 199 participants, particularly during COVID times. So, so there's both theoretical driven effect sizes as well as practical, this is what I can do. Okay. Let me just take a breath and take some questions if there are any. Where is the decision tree in the app? So here is the app. It's, by the way, it's web-based. And then it's you have these broad tabs here and decision trees right there. Okay, please raise your hand. Okay, I don't see decision tree. Well, there you go. All right. Okay, log in.
And then we have one in the Q&A.
Okay. Either that or I'm like totally losing everybody. One of the two, but we'll find out here.
Or they
I'll
all
start
know the
asking
analysis.
questions. Huh?
Or it went really well and everyone knows the
Or it
analysis.
went really well. Okay. Yeah. All right. How many analyses can I do per month? So there's kind of 2 answers to that. Certainly you can do as many analyses as you would like, okay, per month. However, we do have a limit of the discussion draft. That's a big deal. That is a 20, 30-hour time saver. Once you've conducted analyses, any analyses, you can run a discussion draft which will look to AI to interpret your findings in context. This is similar to what we found. This is different than what we found, and so forth. So that's a really great tool. We don't charge an extra penny for it, and I think the tool is darn cheap to begin with. What is the tool, Melissa? 80 bucks, 90 bucks? What is it? A month?
It's $59 a month.
50. It's too low. So 50, so it's really inexpensive. to be able to get results. By the way, I help people in an hour to do chapter 4 and chapter 5, a draft. You have to put in your own voice, you have to understand it, you got to get a discussion, but it gives you a lot of information to start evaluating and putting together. So that's a huge deal. So uh, the analysis, unlimited, although if you're doing 200 of them, I'm going to question what you're doing. And then discussion draft, 5 per month. Okay. I don't see any other questions. Um, where is everybody? Melissa, maybe put out the survey to them and
The
see.
survey comes at the end, but once, yeah. But if you guys want to put in, where you are, if you're struggling with something, anything you want to see, or if you have your research questions and you're unsure about the appropriate tests, we can help you there too.
Let me help you. We're sitting here because I'll go off into other things. So please do share your question or concern. While we are waiting for any of that, I mean, and certainly, as I say, you can contact us and it can help you if you come to a question later on. Let me just briefly mention that we do have let's get here, Intellectus. I have to spell this correctly. So let me just state that we also have a lit review and a qualitative tool. That's a time saver. Inside of you can just go to intellectus360.com. And in the tool itself, when you go to conduct analyses, it's, we made it simple as pie. Lots of DMPs are doing, paired sample t-tests. And basically, I selected the test. I put in my 2 variables, pre and post, and hit calculate, just to give you a flavor of what the output here is.
And we had Kathy just put in the chat that she's looking at fall rates in med
Great
surg
question.
pre and post. So it's
Great question. So for just as an example of the output, you can see for this t-test, assumption is built in, it's actually conducted and then interpreted, and then the results are in plain English. Yippee skippy, we found significant differences, which is often what we're looking for. One way of reporting it, not the only way, and then the interpretation. That goes for all of the different tests. Assumptions built in, interpreted, in particular the quantitative assumptions, um, and then the interpretation of the results with APA tables, with scroll overs. You can see the actual effect size here now. Okay. 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 So, Kathy, good question. So you've asked a question that is outside of the decision tree. So when you have different rates or different proportions, as many places do, really we are in a proportion test land, okay? And if you have 2 proportions, it's 2. If you have 1 proportion versus some testing variable, it's 1. But let's just say, proportion 1, let's just go, pre-fall. I have a sample size of 100. Okay. And I have, a 25% fall rate. All right. That means the nurses are tripping everybody. Okay. And then you have some 25% fall post. Okay. I'm just putting in names, sample size of 80, say. And this proportion has gone down to 0.01. So it really made a big difference that I want to test 2 proportions, say 2 proportions z-test. I'm comparing a 25% proportion of my first sample, and then a post, I have some other sample, and then you can just calculate that, hit calculate, and you can see normality assumptions built in, and then the results, yippee skippy, we found differences in the right direction. Okay, right? The proportion has fallen and it's statistically significant. So good question. that comes up enough that we should probably add it to the decision tree. So I appreciate the question. Okay, other questions we have. Okay, in my study examines grief intensity in adults. So my question there would be, how is intensity rated? Is it intensity low, moderate, high, ordinal, or is it scale? Primary predictor. So let's just talk about that. So that's an important thing, right? So we need to know that level of measurement there. And my primary predictors are gender, age. Oops, I keep missing this back and forth. Okay. So, and my primary predictors there are gender, religiosity, SES, with perceived support as a proposed mediator. I've not talked about mediators. I also plan to include age, time since loss, ages, covariates. I mean, you're throwing lots of stuff in there. Okay. Um, I'll show you you know, so you're throwing lots of stuff in there. So let's just go to basic models of mediation. So it's under advanced, which means that you have some knowledge of regression before that. And then we have different models to be had here. Okay. Um, I mean, before any covariates are thrown in there, I'd want to make sure that that covariate is related to the dependent variable. So that's one thing. So first thing is let's simplify the problem. Okay. Um, and Melissa, we can ask, but I think um, okay, so if you do have covariates, you can put them there. And I think we're only allowing for one. So you can put covariates in there, okay? Um, Primary predictors. So yeah, I mean, you might want to consider just breaking that problem down by looking at one at a time. I think otherwise, I don't know what your sample size is, but you're kind of into like structural equation modeling kind of stuff, where you have all of these covariates and all of these predictors on some outcome variable. Because I don't think that, um, we do have some variations here, um, but I don't know if they're going to handle what you're doing there. So my quick thought is, simplify the problem, get rid of the covariate if you can, look at them individually to begin with, and then kind of move through that. Okay. Like help with the research question. Okay, so let me,
And we have some in
uh,
the Q&A as well.
thank you. I mean, I mean, you know, these, well, I'm not quite sure. And I mean, you have a lot of stuff going on here. Um, So, if you're going for articles or if you're going for a PhD, I presume, um, I think the very often with research questions, I see people stack lots of things in there. And what I do is try to break it up into some manageable bite-sized things. It's like, how do I eat an elephant? You don't. You take a leg or you take a toe, and then you start biting into it that way before, just because your brain says, I want to look at all these things, that doesn't mean that's the most efficient mode of doing that. So to try to keep things simple without getting into structural equation modeling kinds of situations. Okay, how many analysis can I do per month? Okay, so I'm in the Q&A. Oh, okay. Okay, I have a research question. How prevalent is postpartum anxiety? Again, let's assume that that's a scale level variable. When a study population of women, with a study population of women during the year after giving birth. So to me, that's a very just descriptive question. I have postpartum women. I've looked at them 1 year after, and I'm assessing their perinatal anxiety score. That sounds like a how prevalent. It's a descriptive question. Um, So that's what that looks like to me. How prevalent are the subscales of PASS, perinatal anxiety, acute, general, perfectionism, control, trauma within the study population? Again, when talking about prevalence, that sounds very descriptive in nature to me. So I think I would start there. And by the way, if you're students, you're already paying faculty, you know, put descriptives. I'm going to be running frequencies, okay, frequency percentage, or the mean and standard deviation, and run it by them. Evening, prof, evening. I want to verify I could use both I can use a Pearson and Spear in determining the strength and direction of association between international migration and provision of basic services. Again, my mantra for this hour is how are things measured? So, are the provision of basic services like water, is that yes or no? Is that hours per day? Just spoke to somebody from Ukraine. Evidently, they have 2 hours of electricity per day in lots of parts. Not easy in the cold. So how is that measured? So, if in fact water is measured, yes, no, we have access. If water is measured as, inadequate, somewhat adequate, adequate, we're drowning in water. Okay. All right. So if you have ordinal levels of measurement, uh, you have ordinal and scale. Okay. Or if water is by gallons available. So the level of measurement is key here. Um, So in general, the Pearson is scale with scale. Once you have an ordinal level of measurement, once you have ordinal in the mix here, okay, you're in Spearman world. Once you have scale and scale is Pearson. Okay. Uh, okay. I'm currently at Gold Coast. Hi, Dawn.
Would it be
Uh,
helpful if I unmute for these?
well, let me just read. No,
Okay.
I'm okay. Um, Looking at rating confidence in management psychiatric. Again, what's the level of measurement? The measurement instrument is palliative care with adaptation of items 6 through 10 to align with psychiatric symptoms. Fine. By the way, you should be using validated instruments where you can. You can adapt them. You can take pieces of them. But you likely do not want to create your own instrument. Um, because your IRB is going to ask you how you know that those are valid and reliable, and you're not going to have a good answer to that. So you want to, I like that you found a scale and that you're adapting it. Adapting is okay. The original scale structure item format, Likert scales. Um, Terminal illness. Okay, the original scale item format. So let me just say something about Likert type items, which I think can apply to folks. Very often, survey instruments are on a Likert scale. Something like strongly disagree through neutral to strongly agree, which can be considered ordinal. But once you start adding them, okay, summing them or averaging them, you're in scale land. So let me get back to the research question. So now that we know the scale, that it is scale, the survey instrument scale. So, okay, so I think you're just asking about the level of measurement. So I hope that I answered your question. Um, so yeah, so even if it's adapted or not, what you're going to sum or average those items. You're not going to look at those individually. Again, once you start averaging them or summing them, you're in scale land. I think that's the nature of the question. Other questions?
We have a hand raised.
Okay. Ashley's raising her hand.
No.
Okay.
Baruch, you're unmuted if you.
Hi, Baruch. Hello, Baruch.
All right, we have another hand raised, or maybe
Okay.
we don't. Okay, that went down. Oh, we do. Okay, we have another hand raised, so I'm gonna
Okay, and there's more
go to
messages
that
coming
one.
in. Okay, hi, Sandra.
Hi, how are you?
Good. We've talked before, haven't we?
I think we did. Initially, I wasn't at this level at the time that I spoke with you. So now I'm a little further ahead, and I need your help.
Here to help.
Okay, so I know, I have the email to reach out to you. I'm getting ready to go into the chapter 4, chapter 5 realm, and so I put on the chat just one of the questions. I'm in healthcare, and so I'm struggling with the right statistics. I did the G power, I got a sample size, but I'm not really confident in it. I mean, I put it in, I'm getting ready to do my proposal, but I'm just not satisfied. So I figure I would take and listen to this and get in touch with you later on to see if I am on the right track. I think my superiors in the faculty actually suggested something like a chi-square. I did talk about t-test. I did the G-power, but I don't understand it.
So let me put you on the spot here. So chi-squares and t-tests are very different.
Yes.
So what are the levels of measurement of your variables? Let's just take one research question or one study aim and tell me what are the variables involved here?
Um,
Just take one of them.
okay, so one of them would be the transthoracic echocardiography, which is a imaging modality. And so,
And how is that measured
well,
with respect to nominal ordinal scale? How are you measuring that?
um, would I be relationship?
Well, before we get to relationship, let's just talk about the level of measurement. How is that imaging being, at the end of the day, how are you recording that imaging? Like, you know, uh, good or not good, like nominal, or is it levels of amount of dark spots on the imaging and
That
how
would
are
be
you
quality.
quality? Great. How are you measuring quality?
Hmm. Well, as a clinician, our quality would be uh image image quality would be non-stop optimal. So sometimes it has variables in terms of patient body habitus. So when you talk about doing imaging and ultrasound, the quality is measured by the interpretation of what the cardiologist can see when he's reading it. So
Okay.
let me see.
So the cardiologist reads it, and what do you get back for data with respect to that image?
We get we
What is
get
the report? What are the options of the response back from them?
they're able to give an interpretation about heart structure. Is it normal? Is it within the required measurements of ejection fraction measurement, contractility, things like that. And so my argument is, uh, and the literature is saying that this imaging modality is overutilized on aging adults that
So
have been.
wait, I'm not getting into the literature.
Okay, all right.
I
So,
want to stay focused
all right.
around what kind of data are you going to take from that image reader around the image? Are you going to then classify as normal or not? Are you going to have different levels of normal, like suboptimal, optimal,
Yes, exactly. Exactly. Okay, you broke it down a little better for me to understand. Yes, the measurement afterwards will come up if it's normal or abnormal.
Perfect. Normal and abnormal. What level of measurement do you think that is?
Um,
Look at
hold
my
on.
slide.
Hold on. I had my okay. Um, I think that oh gosh. I don't know.
So it's going to be nominal because even though we may prefer normal to abnormal or not normal,
Oh,
you have two labels, normal and not normal.
okay.
So again, if there was gradations of normality, okay, then that would be ordinal if there's different levels in there that
Okay.
are ordered from suboptimal to partially optimal to, optimal or something of that sort.
Okay.
Then you're in ordinal land. But so for everybody on the call, you really need to think about what data am I literally going to put into the tool? It's not that people are reading it, we get that. But
Mm-hmm.
how are we measuring that? Okay,
Okay.
that's the key thing. And you
Okay.
need to think about that because you cannot get to the data plan, okay, without that information. So you
Mm.
have to think about at the end of the day, I'm going to get that report. What am I taking out of that report to put into a cell into my data sheet?
Okay. Okay.
All right. It's
I
either a
understand.
number or it's a level or it's a nominal, not normal kind of nominal.
Hmm. All right. Well, then and just for the sake of saying what you just said, an ejection fraction is a number, so that would be a level. Um,
Well, okay. So it's a number. What does that number range from?
well, the normal ejection fraction is rated at 55 to 65. So anybody that have an ejection fraction less than that, there there still can be a level of normalcy, but if the ejection fraction isn't exactly in between those numbers, it can be considered abnormal. Particularly like a 17% ejection fraction would basically say that that heart has no contractility.
Okay. So you bring up something important, which is sometimes the we can take a variable and it can be measured in several ways. For example, if I literally have an injection fraction from zero, I guess you'd be dead, but 0 to 100, okay, I have a number that's perhaps scale. I
Mm-hmm.
can take that number of 55 to 65 and say, oh, that falls into the abnormal category. Okay. All right. So I'll just give a quick temperature example. I can literally have a temperature from, let's just say, from 0 to 100. That'd be a scale level measure of temperature. I could also put that into ordinal level, very cold, pleasant, hot.
Okay.
30 degrees or less is cold, 30 to 50 is optimal, 50 more is or whatever is hot. So I can take that same temperature number that was scaled and make it ordinal. Or I can dichotomize that, okay? Like whatever. I can make things up. Miserable and not miserable, okay?
Okay.
So you can chop it up in different ways. The basic rule of thumb there is that you want it as grainy as possible. So
Okay.
if I have temperature and I just say miserable versus pleasant or something, okay, I'm losing all that information that, unpleasant is from 40 degrees or less and pleasant is from 41 degrees higher. There's two problems with that. One, you're losing information by bucketing data. The second problem is that some area that's got a temperature of 39 and some area's got a temperature of 41, they're very close to each other, but they're in different buckets. So the basic rule of thumb is keep it grainy, keep it, you know, 55 or 65 or 75% infraction, and then we can choose, okay, hey, maybe we really do want it to be, abnormal or not. but you can easily bucket it thereafter.
Okay.
But you can't go the other way around. You can't bucket it and say, I'm getting data from the reports, normal versus not, but I really don't know what that infraction rate is. So you keep rule of thumb, keep things grainy. You could always turn it into buckets. I mean, unless you know absolutely positively, I only need buckets, normal and abnormal, no problem. I have a dichotomous variable, let's move along.
Wonderful. Thank you.
My pleasure. Look forward to seeing you. All right, who else do we have here? I think that's. Do we have anything else?
No, I don't think.
Edwin, can I conduct SEM? So yes, we can conduct SEM, and that's under analyses. By the way, sample size, you're going to want to have something north of, 150 folks, roughly speaking. Other folks with more complicated questions, feel free to get on my calendar. Again, this is kind of for a general audience, I'll say. So you can, sorry, from the current slide, you can, if I can get there, you can reach out to Samantha or Ashley or get to the QR code, and then we do a free 20-minute consult to figure out, if we can help you, and if so, how. Any final questions here? We're kind of okay.
I think we're okay. I think there might have been some that got lost in the chat, but if we didn't get to your question, please email us.
Yep. And then also share this with others. I mean, you're not the only person that wants to know about um, data analysis plans. So feel free to share it. We'll update you with upcoming webinars. We've kind of changed things around a little bit, so we've kind of freshened them up a bit. And share our tools, our webinars, and stay safe and have a wonderful weekend. And with that, we'll close out for the day and see you all next time. Bye-bye now.